Let's take a look at the application to use the method of Lagrange multipliers to find the optimized value of the function subject to the given constraint. A company has a plant in Minneapolis and a plant in Scranton. The firm is committed to produce a total of 169 units of a product each week. The total weekly cost is given by CXY equals 1/3 x squared plus 1/9 y squared plus 45x plus 59y plus 100, where x is the number of units produced in Minneapolis and y is the number of units produced in Scranton. How many units should be produced in each plant to minimize the total weekly cost? This problem is to find x and y that optimize the cost, which is this function, for the constraint given by the problem is the total is 169 units. So that means x plus y must be 169 units. Therefore, the gxy or the constraint equation is in form of the expression equals 0, gonna be x plus y minus 169 equals 0. So this is the gxy. The steps of using the Lagrange multiplier. First one, we're gonna form the Lagrange function, the capital F. In this case, the function is given as a cost function, so cxy plus the Lagrange multiplier lambda times the gxy. So our Lagrange function is in the form of 1/3 x squared plus 1/9 y squared plus 45x plus 59y plus 100 plus lambda multiplied by g, which is the x plus y minus 169. Step number 2, we're gonna find the first order partial derivative with respect to x, the first order partial derivative with respect to y, the first order partial derivative with respect to lambda. Let me copy the whole expression and then we work on the partial derivative with respect to x. I'm going to highlight the terms involving x. So we target on those when we find the partial derivative. That means the partial derivative with respect to x is going to be 2/3x plus 45 plus lambda. And then the partial with respect to y, we will treat y as the variable and the rest gonna be the constant. Look at y term here, y term, y term. The first order partial derivative with respect to y is 2/9 times y plus 59 times y plus lambda. And the last one, we find the partial derivative with respect to lambda, which technically turns out to be the gxy function or the constraint function. Next, step number 3, we are going to solve the system that fx equals 0, fy equals 0, and f lambda equals 0. In this case, we have 2/3x plus 45 plus lambda equals 0, 2/9 y plus 59. Actually, this is 59, sorry, this is 59 plus lambda, sorry about that, plus 59, and then plus lambda equals 0. And the last one, x plus y plus 169 equals 0. So for the first two, they are involving lambda. So we can already write the lambda in terms of the x and the lambda in terms of y respectively. So we have lambda equals -2 over 3 x minus 45. The second one, the lambda equals -2 over 9 times y minus 59. Then we equate them. So -2 over 3x minus 45 equals -2 over 9 times y minus 59. To write it in the convenient way, we just multiply all by negative sign. So the equation becomes 2 over 3x plus 45 equals 2 over 9 times y plus 59. And then simplify the terms. I'm gonna write y in terms of x, so subtract 59 both sides. That becomes 1, so subtract 59 both sides. We have 2 over 3 times x minus 14 equals 2 over 9 times y, and then multiply both sides by 9 over 2. Then we get y in the terms of, this is 3x, so multiply over, and then minus 63. That's the y expression. And then we're gonna replace the y here with 3x minus 63. So we got x plus 3x minus 63 minus 169 equals 0, or 4x minus 63 minus 169 equals 0. 4x equals, so these two numbers is 232. So move it over to the other side. And then x is 232 divided by 4. And turns out to be 58. If x is 58, y is 3 times x minus 63. And it is 111. That is the same as the given solution here. So 58 units in Minneapolis and 111 units in Scranton.